reflection of a plane wave at normal incidence. Reflection of a plane wave at a normal incidence. Suppose I am considering two medias. This is medium 1, medium 2, two different mediums. The properties of medium 1 has some conductivity sigma 1, epsilon 1, mu 1, eta 1, characteristic impedance or intrinsic impedance eta 1. Similarly, it has sigma 2, epsilon 2, mu 2, the intrinsic impedance some eta 2. That is two different properties. Suppose a wave is incident normally like this. Incident wave EI. So, some part of the wave is reflected back, which is ER, and some part of the wave is transmitted, which I am considering as ET, transmitted wave. This is reflected and transmitted. Suppose this is some Z is on Z is equal to 0 plane. Z is equal to 0 plane. So here the electric field is E1 in medium 1 and the electric field in medium 2 is E2. This is normal incidence situation. Then I can relate directly, here I am writing the equations, how I can relate this reflected and incidence, transmitted and incidence is the reflected ER, the reflected by incident electric field, ER by EI. This is also known as a reflection coefficient. Reflection coefficient. ER by EI is equal to tau. Reflection coefficient tau is given by eta 2 minus eta 1 by eta 2 plus eta 1. Eta 2 minus eta 1 by eta 2 plus eta 1, where eta 2 is intrinsic impedance of medium 2. Eta 1 is intrinsic impedance of medium 1. Similarly, ET transmitted by incident, which is known as a transmission coefficient, is given by, indicated with the T, is given by 2 eta 2 by eta 1 plus eta 2. 2 eta 2 by eta 1 plus eta 2. Similarly, H field also we can relate. HR by HI is opposite to the ER by EI. Eta 1 minus eta 2 by eta 1 plus eta 2. HT by HI is given by 2 eta 1 by eta 1 plus eta 2. So we have to keep in mind these relations to solve the problems. One more interesting here is, suppose medium 2 is a perfect conductor. Medium 2 is a perfect conductor. Medium 2 is a perfect conductor. Perfect conductor means sigma is infinite. Then what is the eta 2 value? Perfect conductor means eta 2 intrinsic impedance is 0. Then what happens? What is the reflection coefficient tau? Tau is minus 1. Transmission coefficient is 0. Transmission coefficient is 0. What it means? Tau is equal to minus 1. ER by EI is equal to minus 1. Therefore, ER is equal to minus EI. That is, ER is equal to minus EI. So, reflected is nothing but opposite of incident. That is, the total wave is reflected back. The total wave is reflected back. And transmission is 0. Transmission is 0 means E2 is equal to 0. Transmission is 0 means E2 is equal to 0 because E1 is nothing but EI plus ER. E1 is nothing but EI plus ER. So that is the total wave is reflected. If medium 2 is a perfect conductor. We know that what is the electric field inside a perfect conductor? Inside a perfect conductor, electric field is 0. Field vanishes. So this is true here. The total wave is reflected back when medium 2 is a perfect conductor. So this reflected wave combines with the incident wave to form standing waves. So this standing wave concept we will discuss more clearly when we are discussing transmission lines. Just here the standing wave ratio formula I am giving here, that is given by standing wave ratio VSWR. That is VSWR is given by the standing wave ratio. VSWR means voltage standing wave ratio, maximum voltage by minimum voltage, the ratio of magnitude of maximum to minimum, Emax by E minimum. So we will discuss more about this standing wave ratio concept when we are discussing transmission line concept. So just for now, time being, consider standing wave ratio is nothing but maximum voltage by minimum voltage or maximum current by minimum current, or maybe it will be same for both. So here very important conclusion is, if the medium 2 is a perfect conductor, then the total wave will reflect back, which forms some standing wave. Suppose we will work out a simple problem based on the concept what we discussed. Problem is, when a plane wave traveling in free space is incident normally on medium having epsilon r is equal to 4. The fraction of power transmitted into the medium is given by option A 8 by 9, option B 1 by 2, option C 1 by 3, option D 5 by 6. This type of problems are very important, so we will see how to solve this type of problems. The solution to this problem is, here two mediums are given, medium 1, medium 2. Medium 1 is free space, medium 2 is characterized by some epsilon r value 4, mu r value is not given, we have to consider as 1. Then the wave is incident normally. What is the fraction of power transmitted into the medium? First of all, we will calculate what is the electric field in medium 2. That is, what is the transmitted wave amplitude. We know that the transmitted electric field by the incident is given by 2 eta 2 by eta 1 plus eta 2, where eta 2 is the intrinsic impedance of medium 2, eta 1 is the intrinsic impedance of medium 1. So here eta 1, intrinsic impedance of medium 1, there is a free space 120 pi. Eta 2 is equal to how much? What is the difference? Eta 2 is nothing but mu by E epsilon. That is nothing but mu naught to mu r by epsilon naught epsilon r. So this is nothing but 120 pi divided by square root of epsilon r, because mu r is equal to 1. So epsilon r is given 4, nothing but 60 pi. Eta is equal to 60 pi. Therefore, Et by Ei is equal to 2 into 60 pi by eta 1 120 pi plus 60 pi. So that is nothing but 120 pi by 180 pi. So this is nothing but how much? So pi cancels out, 0 0 cancels out, 6 2s 6 3s, so 2 by 3. Et by Ei is equal to 2 by 3. Therefore, Et is equal to 2 by 3 Ei. This is the transmitted electric field magnitude, but they are asking what is the power, percentage of power transmitted into the medium. So then what I am doing, Et square is equal to 4 by 9. Et square is equal to 4 by 9 Ei square. What is the power? I know power is equal to, average power is equal to E square by 2 eta generally. So what I am doing here is Et square by, here I am making it as 2 eta 2, so that the total thing becomes power transmitted, average power transmitted is equal to 4 by 9 Ei square by 2 eta 2, so that it will cancel out, and I am multiplying with numerator 2 eta 1, so that Ei square by 2 eta 1 becomes power incident 2 eta 1. So this is equal to 4 by 9 Ei square by this factor, Ei square by 2 eta 1 is nothing but power incident into eta 1 by eta 2. This factor is power transmitted. So power transmitted is equal to 4 by 9 into power incident into eta 1 by eta 2. So eta 1 by eta 2 is nothing but how much? 120 pi by 60 by 2 is nothing but 8 by 9 power incident. So power transmitted is nothing but 8 by 9 of power incident. The fraction of power transmitted into the medium is given by 8 by 9. So the power transmitted is here is nothing but 8 by 9 of power incident. So which one is correct? Option A is correct. So like this we can solve this problem. Otherwise we can solve this problem in another way also. First of all, calculate the voltage reflected, that is ER by Ei. ER by Ei is nothing but eta 2 minus eta 1 by eta 2 minus eta 1 by eta 2 plus eta 1. So what is the thing? Eta 2 is equal to 60 pi. So 60 pi minus 120 pi minus 60 pi minus 60 pi 1 by 80 pi minus 1 by 3. Now ER is equal to, ER square is equal to 1 by 9 Ei square, because both incident and reflected are in same media. So this is nothing but ER square by 2 eta 1 is equal to 1 by 9 Ei square by 2 eta 1. So this is nothing but power reflected is equal to 1 by 9 power incident, 1 by 9 power incident. So the reflected power is 1 by 9. Then what is the power transmitted? Power transmitted is nothing but 1 minus 1 by 9. So 8 by 9 of Pi is transmitted. So this is another way to solve this problem. So this will take very less time comparing with transmitted, or you can solve in any either way. But you must be careful when you are going directly with the transmitted wave. Here dividing with the 2 eta 2 factors. Next problem is based on this concept only. Problem number 2. The problem is like this. A uniform plane wave incident normally on a plane surface of dielectric material is reflected with a VSWR of 3. What is the percentage incident power that is reflected? A uniform plane wave incident normally on a plane surface of dielectric material is reflected with a VSWR of 3. What is the percentage of power that is reflected? The solution to this problem is here VSWR. I am relating this VSWR with reflection coefficient is VSWR is given by 1 plus mod tau by 1 minus mod tau. We will discuss this concept more clearly in transmission lines. For now, you consider the formula for VSWR is 1 plus mod tau by 1 minus mod tau. This is the formula for VSWR in terms of reflection coefficient. Here it is given 3. So calculate first of all reflection coefficient. Therefore 3 is equal to 1 plus mod tau by 1 minus mod tau implies what is the tau value? Mod tau value, if you simplify this, you will get 1 by 2. We know that what is tau? Tau is nothing but reflected by incident voltage. Therefore, ER by EA is equal to mod tau, that is plus or minus 1 by 2. It may be either plus or minus. Therefore, ER square is equal to, so ER square is equal to 1 by 4 into EA square, because the incident field and reflected field are in the same medium. So this is 2 eta 1, a medium. So power reflected is equal to 1 by 4 of power incident. What is the question? What is the percentage they are asking? Percentage means power reflected is equal to 1 by 4 into 100 pi. So this is nothing but 25%. So 25% of incident power is reflected. So what about remaining 75%? 75% is transmitted. So here the options given for these questions are 10% option A, option B 25%, option C 50%, option D 75%. So option B is correct. So like this we can solve this problem. This type of problems are very important. Suppose the power transmitted. If the question is power transmitted means directly we can say that 75%. So even though if they ask power transmitted, instead of going for ET by A, go for ER by A. First calculate what is the power reflected, because incident power and reflected power are in same medium. So you don't have any confusion by dividing with the 2 eta 2 to eta 1. So after that just subtract from power transmitted is equal to what is the remaining power. If you calculate, then you can easily get what is the power transmitted. So this is a simple way to solve the problem.